Hello everyone and welcome back to Mathematics with Usman. This is my fifth and the last tutorial in my series on the topic linear inequalities. In this particular tutorial, students, we are going to apply all the concepts that we learned regarding linear inequalities in solving the past paper question. And today the paper that I have selected is O-Level 4024 paper 1. And today we are going to practice its question number 15. In question number 15, students, you are given with the diagram in which the shaded region is satisfied by the three inequalities. And what you have to do is you have to come up with these three inequalities. Students, you can see that this shaded region is bounded by the three lines. This is the vertical line, horizontal line, and the line having some gradient. Let us call these lines the name. The horizontal line is named as L1. This vertical line, let's call it L2, and this gradient line, let's call it L3. Remember, students, the first step is you have to come up with the equation of all three lines L1, L2 and L3. So let's first find the equation of the line L1. And you can see that, student, this line is a horizontal line having a zero gradient. So equation of such line is always y equals to the point where they are intersecting the y-axis. So equation of this line is equals to y equals to 3. Now, students, equation of L2, which is a vertical line, is always the point where this line cuts the x-axis, means it's x-intercept. And student, this line is intersecting the x-axis at 5. So the equation of the second line, which is L2, will be x equals to 5, means it's x-intercept. In order to find the equation of the third line, students, that is L3, you have to come up with two important things. Number one, the gradient of this line L3 and the point where this line cuts the y-axis, means the y-intercept of it. And you can see, students, for its gradient, for 1 unit in x, it is moving 1 unit in y. For every 1 unit in x, it is moving 1 unit in y. So the gradient of this line is m equals to 1. And the point where it cuts the y-axis is its y-intercept, means c, that in our case is equals to 1. As we know the formula for the equation of a straight line, y equals mx plus c. Now we have the value of m, we have the value of c. So we can easily substitute them in y equals to mx plus c and get the equation of the line L3, which gives us y equals x plus 1, where m is equals to 1. Now, students, as we have to come up with the inequalities for this shaded region, students, just consider your line L2 and the x coordinate of it is 5. Now, if we consider the region that is on the left side of it, we have to put the inequality x is less than or equals to 5. If I take the value of x that are lesser than or equals to 5, I will get whole of this region. If you consider any point inside this shaded region that I have shaded in blue for you, you will see that, students, every point is having an x coordinate that is lesser than or maximum equals to 5. Now consider the equation of line L1, which is the horizontal line. Equation is given as y is greater than or equals to 3. And students, if I take the values of y that are greater than or equals to 3, I will come up with the region on the right and left of it. This is the whole region which is described by this inequality. Now, students, there is the intersection between these two lines. This inequality indicates you have to be on the left of this line, and this second inequality, which is y is greater than or equals to 3, indicates the region that is above this line. if you want to be on the left hand side of this vertical line and above this y is greater than or equals to 3 line, you see that the point of intersection between these two lines is the region which is on your screens. Now students, there is one and only one ambiguity left in our shaded region. That is what we have to write the inequality for the third line, that is L3, whether we have to put the greater than sign or the smaller than sign for this. Just consider any point that is lying in this shaded region. If I consider x4 and y4, I'll be somewhere here exactly in this shaded region. So let us consider this point for the third line, having the coordinates 4 and 4. If you place the value of x and y in this inequality, we are going to get 4 equals 4 plus 5 or 4. Now students, here you can see that 4 is lesser than 5. So we have to put the sign that is lesser than or equals to 5. If I consider any point in this shaded region, I have to put this inequality sign that will represent this shaded region. However, students, if I take the point that is above this line, just consider the point 0, 3. This point is above this line, y is equals to x plus 1. Now, if you replace the values of x with 0 and y with 3 in the given equation, you will get 3 equals to 0 plus 1, which means that the value of 3 is greater than 1. So if you need to shade the region above this line, you have to put the greater than or equals to sign, and if you need the region that is below this line, you have to put the lesser than or equals to sign. Since students, we have the region below this line, so we have to put the lesser than sign for line number 3. So students, the 3 inequalities that you have to come up for this region satisfied by the 3 inequalities will be given as: number 1, your y should be greater than or equals to 3, your x should be lesser than or equals to 5, and your other region must be below this line, which is this one. So these are the 3 inequalities that are satisfying this shaded region given in your figure. And students, this brings us to the end of today's tutorial. I hope this question will help you in solving the questions regarding linear inequalities in your past papers. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.